Recording in progress.
Okay, good morning. I'm starting now. Am I
Good
audible?
morning, sir.
Good morning,
Yes, sir. Yes, sir.
Okay. Yesterday we have seen standing waves whose equation is this and amplitude is this much है ना ये वाला amplitude है और जिसमें जिसके amplitude में sin x होता है sin के x वाला टर्म है node will be at origin x is equal to 0 means amplitude will be 0 है ना तो origin पे node बनना है तो इक्वेशन में sin के x आएगा amplitude में and if there is antinode in at nodes at origin then here it will be cos kx यहाँ पे cos हो जाएगा ये sin हो जाएगा both terms will interchange if antinode is at origin. So this is the equation we have derived and also we have seen nodes and antinodes. Nodes are those particles which don't vibrate at all. Nodes are particles of maximum vibrations, distance between two successive nodes and antinodes are lambda by 2, half wavelength के distance पर रहते हैं. They are at the distance of half wavelength, either nodes or antinodes. And this equation में nodes will be at origin, antinodes will be at origin, and other points remain same. There is no other changes. We are discussing 4. You are supposed to write 4 points, 4 differences. Could you get the 4 differences? देखो if we see 2 particles on either side of the node, देखो ये node है and this is the particle 1, this is the particle. When this particle goes down, this particle will be going up. Right. Half of the segments. Okay, we'll see this side. All the particles together will be crossing the mean position. If ये ऊपर जा रहे होंगे तो ये नीचे जा रहे होंगे. It means 2 particles on either side of the node will be out of phase by 180 degree. जब ये ऊपर जा रहा है तो नीचे जा रहा है ना ऐसा. तो phase difference between the 2 particles on side of nodes will be 0, but phase difference between 2 particles, the 2 nodes, ये यहाँ से आता है, will not be there. All the particles are crossing the mean position together. तो 2 nodes के बीच के particles in phase है और adjacent nodes के one side and another side, they are out of phase. ऐसे एक इधर जा रहा है एक नीचे जा रहा है. It was the question here. What is the phase difference between 2 particles on either side of any nodes? 180 degree. There is node, this particle, if this particle goes up, this particle will go down. So this is the one of the difference. You can write this, include in these points, you can include in differences. यहाँ पर कि in progressive wave all particles are having same amplitude. इसमें amplitude different है. And other particle you can write दो nodes के बीच के particles are in same phase, but progressive wave में they are not in same phase. This first particle is going up, then ये बाद में जाएगा ऊपर, है ना? Progressive wave में progressively all the particles are going to the same amplitude, one by one. They are not in phase. They are out of phase, having some phase difference. यहाँ पे एक साथ वाइब्रेट करते हैं nodes के बीच के. and energy is not transferred because these particles are not vibrating, so energy doesn't go this side or this side. उसमें energy transfer होती progressive way में. Amplitudes are same, amplitudes are different. So these points you can include. You can just note down from your textbook. और क्या ऐड कर सकते हैं इसमें? ये मैंने बता दिया. What is the phase difference between any two particles between two consecutive nodes? No phase difference. They oscillate together. एक साथ ऊपर जाते हैं, एक साथ नीचे आते हैं. The part of the node, they will be going together up. ठीक है. So you can go through to textbook and you can write the points. Stationary wave is obtained by the superposition of two identical waves in moving in opposite direction. Progressive wave is just one wave. Progressive wave is a single wave. This is a combination of two waves. There is antinodes and nodes in the stationary wave, whereas no such thing in the progressive wave. ये सब पॉइंट लिख सकते हैं आप. This question we were doing है ना. So wave traveling towards the positive axis, ये वाली नेगेटिव वाली जिसमें नेगेटिव आता है ना. तो ए का आंसर हो गया आपका 1 और बी का क्या था? Are you there?
Yes.
Yes, sir.
Towards
Yes.
yes. Towards
Yes.
negative कौन सी जा रही है जिसमें पॉजिटिव आता है बीच में? तो 3 हो गई. और सी में क्या आंसर आएगा? वेव्स गोइंग इन अपोजिट डायरेक्शन. तो ये वाली होगी. अपोजिट डायरेक्शन में जाने से दोनों आइडेंटिकल है. देखो अपोजिट डायरेक्शन में जाने से स्टेशनरी वेव बन जाएगी. सी का 2 आएगा. Getting or not? In place of writing which one is the stationary wave, they are asked waves going in opposite direction. Since they are identical and going in opposite direction, they will form this type of wave called stationary wave. Got it?
Yes, sir.
इसमें दोनों टर्म्स हो गए.
Yes, sir.
5x का सेपरेट हो गया और 40 का सेपरेट हो गया. The terms get separated with the one is with the sine, other is with the cosine. Such waves are called stationary waves. But yeah, these two waves, तो यहाँ पे 8 जाना चाहिए. 2a आता है. This must have been formed. This must have been formed with some other waves. है. इससे नहीं बनी होगी. Because यहाँ पे 2 होता है. Then did you notice outside 2a was coming? Certainly
Yes, sir.
waves moving in opposite direction and making the stationary wave.
Yes, sir.
ठीक है. So now we'll see the NCERT book question. ये देखो ये question है आपका. Can you do this important है? Question number 11. Read it and do it. देखो कैसे करेंगे. Understand the question first. आया समझ में?
Yes, sir.
How to do the
Yes, sir.
all the parts? मैंने फर्स्ट पार्ट बताइए. This is the equation given. X and Y are in meter and time is in second. The length of the string is 1.5 and its mass is this much. तो इससे क्या मिलेगा आपको? Length is 1.5 meter and mass is 3 into 10 power minus 2. तो यहाँ से आपको m/l मिल जाएगा. m/l किसको बोलते हैं? मास पर यूनिट लेंथ, लीनियर मास डेंसिटी. टू इंटू 10 to the power minus 2. Okay. And what about first part? Does the function represent traveling wave or stationary wave? किसकी equation है ये? Is it equation of traveling wave or stationary wave? Yeah.
A stationary wave. A stationary wave.
Yes. Second part. Interpret the wave as a superposition of two waves traveling in opposite directions. What is the wavelength, frequency, and speed of each wave? The waves which are making this stationary waves. What is the wavelength of that wave? And frequency also, speed also. Wavelength and frequency को multiply करेंगे, speed मिल जाएगी. How to get the wavelength first? Wavelength कैसे निकालेंगे बोलो? Are you there?
Yes.
How to
Yes.
get the wavelength? Yes, anybody?
So in this equation cos omega t. So here it is equation cos omega t. So here it is cos 125. So omega will be equal to 125. So omega will be equal to
Yes.
125.
So
So
will
that
the
will
omega
be-
give us the wavelength?
So that will
Yes.
be the.
What about wavelength?
So then we can find. So then we can find.
Okay. In these, always we are seeing whether it is stationary wave or traveling wave, coefficient of t will be omega.
Yes.
Coefficient of x will be k.
Yes.
K is equal to 2 pi by 3 from equation K is, अगर इसको कंपेयर करें, y is equal to 2a sin kx into cos omega t. These are the standard waves. तो x का कोएफिशिएंट k होता है, which is given 2 pi by 3. कॉमन तो नहीं है बाहर, कुछ कॉमन नहीं लिया ना. If it is there, you multiply inside and then equate. So outside is nothing. It is only 2 pi by 3. तो k कितना होता है? 2 pi by lambda, which is 2 pi by 3. 2 pi goes. Therefore, lambda is equal to 3 meters. Got it? Lambda की value 3 meters. Yes, right. And x f निकालने के लिए, frequency के लिए, omega is equal to 120 pi. Omega is nothing but 2 pi f. Therefore, f कितना आएगा? 60. 120 divided by 2 is 60. Pi also getting cancelled. Yeah. Clear?
Yes, sir. Yes,
What
sir.
about the speed? V is equal to
Sir, A 180.
Wavelength into frequency.
Sir, A 180.
Wavelength into
wavelength
frequency.
into frequency. So frequency is 60, wavelength is 3, 180 meters. All are in SI unit given earlier. And so we don't have to convert. And determine the tension in the string, C part. Yeah, how to get the tension in the string.
So T is equal to root YG. T is equal to root YG. So we will,
Root YG. No,
we
that
will,
was one particular case. That
is
was the
for pulse.
that was the case when
for
no, that
pulse.
was the case when rope was hanging vertically and it had some mass, and of course here also mass is there, but here it is clamped between the two ends. And
Yes. Yes.
so formula is V is equal, general formula is ये फार्मूला होता है V is equal to root of T by mu. तो यहाँ से आ जाएगा V आपका 180 है और म्यू हमने निकाला हुआ है. स्क्वायर कर लो पहले, चलो पहले T को एक तरफ कर लो, स्क्वायर कर लेते हैं पहले. ठीक है, म्यू आपका है, we done it here, 2 into 10 to the power minus 2, 180 का स्क्वायर. ठीक है, तो इफ यू सॉल्व इट, ये आपका आएगा, आंसर दिया हुआ 648. ठीक है, all the parts are clear. These are the important question even for competitive examination also. Any doubt in this?
No, sir. No, sir.
Note down. All right, we'll see the further points of this. That we saw the rope vibrating in loops. At low frequency, the rope fixed at both the ends was vibrating in single loop, then frequency was increased. There were 2 loops, 3 loops, and so on. That particular modes of vibration we are going to see are called normal modes of oscillation of the string fixed at both the ends. The lowest frequency होती है, we call them fundamental frequency. Next available frequency at which it is vibrating in the 2 loop will be called second harmonic or overtone. देखिए ये points, can you see? Oscillation of system by the natural frequency is called normal modes. Natural frequencies, there are many frequencies in the system in which it will be making the 1 loop or 2 loop or 3 loop like that. And lowest frequency is called fundamental frequency or first harmonic frequency available in the system. After the first harmonic is called first overtone and so on. जो lowest frequency के बाद की जो frequency होती है, it is called first overtone. The next available frequency will be called second overtone. First overtone of the fundamental frequency. Simply we call it first OT, second OT, third OT, like that. Okay. So suppose we take the string here और उसको fix कर दे दोनों एंड पर यहाँ पे manually or with the help of oscillator we oscillate it. So at one particular frequency it will make the loop like this. If L be the length, T be the tension, mu be the linear mass density, V is equal to under root of T by nu. Already we have done this point, है ना? और उसके बाद जब frequency बढ़ाएंगे आप, तो it will convert into 2 loops, है ना ऐसे? Actually, by the way, you can see the peak of, yes, let's it up here, sir. If you increase the frequency, this formation will be there. If you further increase the frequency, this formation, 3 loops, 4 loops, and so on. Okay. It is a single loop vibrating like this. And at one point of time, it will be like this. Then this will go this side, this will go this side. Then it will be like this. Since it is oscillating very fast, the camera doesn't pick up the one particular position. It appears as a loop. If you further increase the frequency, 3 loops are formed. So this is called fundamental or first harmonic, second harmonic, third harmonic, and so on. So what will be the frequency of first harmonic? Mode of vibration, also called first harmonic. I mean, first resonance we call it, or fundamental frequency we call it. So let's do. So ये diagram है आपको. I mean, there is the length and this is one half of the wave है ना इतना. I mean नोड और नोड से बीच की जो डिस्टेंस होती है कितनी होती है वो lambda by 2. Just yesterday evening only we did. So this lambda by
Yes,
2
sir.
has to be equal to L.
Yes, sir.
Frequency called first harmonic. From the figure we can see length is in first mode, length is equal to lambda by 2. ये वाला diagram देखो. Lambda is equal to L. So we know the formula, frequency is equal to V by lambda. V is under root of T by mu. Lambda यहाँ से put कर दिया हमने. So it is coming 1 by 2L under root of T by mu. This is called F1. It is F1 is fundamental frequency. F and the fundamental frequency को short में FF लिख सकते हैं. Fundamental frequency or first harmonic. चलिए. No problem so far.
No, sir.
अभी
No, sir.
सेकंड के लिए क्या करेंगे देखो सेकंड में होल लेंथ इज इक्वल टू वन वेव लेंथ विच इज लैम्डा. वन वेव हो गई. और वी कैन से दिस इज लैम्डा बाय 2, दिस इज लैम्डा बाय 2. तो दिस लेंथ विल बी इक्वल टू लैम्डा ओनली. सेकंड केस में सिंगल लूप इज लैम्डा बाय 2 दो लूप बनने lambda by 2 plus lambda by 2 lambda. The second case में L will be equal to lambda. When you increase the frequency, two loops are converted. Second harmonic we get. So let's do second one. What we are doing, normal modes of the splitting string which is fixed at both the ends. एक question आ सकता है. Prove that the frequency, find out the first, second, third frequency. In this case, the second frequency के लिए second mode what we call it is second harmonic, second resonance or second harmonic or first overtone. तो बहुत सारे नाम है इसके. So from figure you can see L is equal to lambda by 2 plus lambda by 2. Two loops है which is equal to lambda, and now F will be equal to V by lambda. ठीक है. तो F is equal to V by lambda. तो V की वैल्यू पुट कर दी, lambda is L. इसको सिंप्लीफाई किया तो ये आ गया 1 by L which is twice of fundamental frequency. इसको F2 लिखेंगे. देखो it is nothing but देखो यहाँ पे देखो it is nothing but 2 into 1 by 2 L into T by mu. तो twice हो गया. fundamental frequency is this much. 2 भी ऊपर आ गया. ऊपर 2 से multiply and divide कर दो. So this thing becomes fundamental frequency. Since it is this frequency, ये frequency कितनी आ रही? Twice of F. Okay. Twice of F1. यहाँ पे ऐसे देखते हैं. So this is called F2. Second harmonic. F2 is known as harmonic or first overtone. इसमें notes कितने बनने हैं? Tell me the notes. First case में notes कितने? Fundamental mode में कितने notes हैं?
2.
और anti notes is 1. इसमें कितने बनने हैं? 1, 2, 3 notes और anti notes are 2. Second mode में anti notes are 2, notes are 3. तो जितने second mode में 2 anti notes, first mode में 1 anti note. और थर्ड में क्या हो जाएगा? 3 loops है. थर्ड हार्मोनिक में whole length is equal to lambda by 2 plus lambda by 2 plus lambda by 2. 3 lambda by 2. Third harmonic whole length is equal to 3 lambda by 2 and F3 will be 3 times of, okay, देखो, L is 3 lambda by 2, therefore lambda is equal to 3L by 2L by 3. तो यहाँ 3 ऊपर आ जाएगा और ये तो V रहेगा इधर, है ना? It is becoming 3 times of your fundamental frequency. F3 is 3 harmonic or second overtone. Overtone एक कम रहेगा, it will be 1 less. Over है वो. First one will be tone, second one will be first overtone, third one will be second overtone, and so on. Anti notes कितने होंगे इसमें? 3. Third mode में 3 anti notes है. Notes is 1 more extra, 1 extra. That's 4. तो इसमें all harmonics, odd and even are present. तो first harmonic था, second भी था, third भी था, तो इसके बाद fourth आएगा and so on. So in this case, all the harmonics are present. Question ऐसे आ सकता है, prove that all the harmonics are present in the string, fixed at both end and vibrating. Okay. You can see this second and third हमने. So there are questions based on this part also. All right, all the modes are clear.
Yes. Yes.
And this one was the first. What is the first harmonic? 1 by 2L under root of T by mu. In fact, it comes from this. F is V by lambda. Suppose आप formula recall नहीं कर पा रहे हैं, तो V की value, V का formula, this already we know. Lambda you can see first mode है या second mode है. You can find out lambda in terms of length of the string. But better you remember this fundamental frequency is the standard one. Second harmonic को twice कर दो, third harmonic को three times कर दीजिए.